Hello, I'm BJ at Seoul National University. In the previous two videos, I discussed Aleph no multiplied by 0 equals 0 and C multiplied by 0 is larger than 0. In this video, I'll show that C is larger than Aleph no. And there are two proofs by Cantor that card R is larger than card N, one by the method of nested intervals and the other by diagonal argument. Later, I'll show that the second proof is flawed. Herein, I present a new proof by order axioms. There are four order axioms in real numbers. Axiom 01 of trichotomy states, if x and y are real numbers, then exactly one of the following is true. X is smaller than or equal to or larger than y, and allows to compare which is larger between the two real numbers. However, Aleph no and C are not a real number, thus are not included in this axiom. In order for C and Aleph no to be compared, it is obligatory that exactly one of the following relations should hold. C is smaller than or equal to or larger than Aleph no. Thus, it is justified to have axiom of trichotomy which includes C and Aleph no. Thus, we'll have O1 prime of trichotomy, which states if x and y are an element in real numbers or Aleph no and C, then exactly one of the following is true. X is smaller than or equal to or larger than y. And there is axiom 04, which states if x, y, and z are a real number and z is larger than 0, then x smaller than y implies xz is smaller than yz. 04 excludes the case of z equals 0 because xz equals yz equals 0 for any xy are in real numbers. Because Aleph no and C are not a real number, they are not included either. And 04 needs to be modified for the following reasons. If z equals 0 and x or y equals c, it no longer implies xz equals yz equals 0 for any x and y. And if z equals Aleph no or c, x smaller than y no longer implies xz is smaller than yz because xz equals yz for any real number x and y. Thus, we need to have axiom 04 prime such that if x, y, z is an element in R or Aleph no and C, and z is larger than or equal to 0, then x smaller than y implies xz is smaller than or equal to yz, or xz is not larger than yz. Then we can prove C is larger than Aleph no. We know Aleph no multiplied by 0 equals 0. C multiplied by 0 is larger than 0. By axiom 01 prime, exactly one of the following should hold. C is smaller than or equal to or larger than Aleph no. If C is smaller than Aleph null, then by axiom O4 prime, C multiplied by 0 is not larger than Aleph null multiplied by 0, which is 0, which contradicts C multiplied by 0 is larger than 0. If C equals Aleph null, then Aleph null multiplied by 0 equals C multiplied by 0, which is larger than 0, which contradicts Aleph null multiplied by 0 equals 0. Thus, C should be larger than Aleph null, which is supported by if C is larger than Aleph null, then by axiom O4 prime, C multiplied by 0 is larger than or equal to Aleph null multiplied by 0, which is 0, and is consistent with C multiplied by 0 is larger than 0. Thus, C is larger than Aleph null. It should be clarified that the symbol multiplication in Aleph null multiplied by 0 and C multiplied by 0 does not denote multiplication between cardinal numbers, but multiplication between counting numbers and real number 0. Aleph null and C are counting numbers in essence, even though they are termed as cardinal numbers. Thus, we can consider multiplication of a certain number by Aleph null or C, which are counting numbers. A certain number can be extended to real numbers in a number line sense. For example, Aleph null multiplied by square root 2 would not make sense in the concept of cardinal number multiplication. However, it makes sense in the concept of a multiplication of a certain number by counting numbers, because it means Aleph null times the length square root 2, which is Aleph null. Thus, the concept of multiplication by counting numbers allows multiplication of real numbers by counting numbers, thus widens the arithmetic of cardinal number multiplication, which limits multiplication by cardinal numbers to natural numbers. If we consider C multiplied by 0 as a cardinal number multiplication, which would result in cardinal numbers only, C multiplied by 0 equals square root 2 would not make sense because square root 2 is not a cardinal number. However, C multiplied by 0 can be square root 2 if you follow the concept of multiplication by counting numbers. These are the arithmetic of 0 in infinity. Please send critical comments to this address. In the next video, I'll discuss 1 over Aleph null. Thank you very much.